Hello and welcome to today's lesson on collision frequency. In this lesson, we will explain the factors that influence collision frequency in the different states of matter, starting with solids, then moving on to liquids, and finally gases. So far, you have developed an intuitive understanding of collision theory. You know that there are two main ways to increase the rate of a reaction based on this theory: by increasing the number of collisions, and by increasing the energy of these collisions. Building on this foundation, today's lesson will advance our chemical understanding by illustrating how exactly we can control the collision frequency for different states of matter, providing a deeper insight into the behavior of chemical reactions in various conditions. Let's dive in. Previously, we learned that the frequency of collisions directly impacts the rate of reaction. Now, let's explore the specific factors that influence collision frequency in solids, liquids, and gases. Starting with solids, particles are tightly packed in a fixed structure and can only vibrate in place. This limits their ability to collide frequently. To increase the rate of reaction in solids, you can increase the number of exposed particles by breaking the solid into smaller pieces or using a powdered form. By doing this, the surface area increases, exposing more particles to potential collisions, which raises the collision frequency and therefore the reaction rate. For example, think about trying to dissolve a sugar cube in a cup of tea. If you drop the whole cube in, it dissolves slowly because only the particles on the surface of the cube can interact with the water. But if you crush the sugar cube into smaller granules before adding it, it dissolves much faster. This is because the smaller granules have more surface area exposed to the water, allowing more particles to collide with water molecules. Mathematically, surface area is directly proportional to the rate of reaction. This means that if we double the surface area, the rate of reaction will also double. In liquids, particles are still close together but can move past one another. This mobility allows for more frequent collisions compared to solids. One effective method to increase the rate of reaction in liquids is to increase the concentration of the reactants. A higher concentration means more particles packed into the same volume, which leads to more frequent collisions and ultimately, a faster reaction. Imagine hosting a party in a small room. The more people you squeeze into the room, the more likely they are to bump into each other. Similarly, increasing the number of particles in a given space increases the likelihood of collisions between them. Again, mathematically, concentration is directly proportional to the rate of reaction. This means that if we double the concentration, the rate of reaction will also double. Finally, let's discuss gases, where particles are far apart and moving quickly in all directions. Because of this rapid movement and the large distances between particles, gases already have a naturally high collision frequency. However, to further increase the rate of reaction, you can increase the pressure. By compressing gas particles into a smaller volume, you increase the chances of collisions between them, which boost the reaction rate. Like with the previous factors, pressure is also directly proportional to the rate of reaction. If we double the pressure, we generally double the rate of reaction. By understanding how particle interactions differ in solids, liquids, and gases, we can manipulate factors like surface area, concentration, and pressure to control reaction rates. This knowledge helps explain everyday phenomena, like why crushed sugar dissolves faster in tea, or why increasing the pressure in a gas speeds up reactions in industrial processes. In today's lesson, we delved into how collision theory can be intuitively understood through the particle model of matter and what factors influence collision frequency for each state of matter. We learned that in solids, particles are tightly packed and fixed, so increasing surface area by breaking the solid into smaller pieces can boost reaction rates. In liquids, particles are close but mobile, and increasing the concentration of reactants enhances collision frequency, and hence the rate of reaction. In gases, particles are far apart and fast-moving, so increasing pressure compresses them into a smaller volume, leading to more frequent collisions. By understanding these principles, we can manipulate conditions like surface area, concentration, and pressure to optimize reaction rates. Watch the rest of the GCSE chemistry course at Sophos Education.